it's me, your maths tutor, and welcome back to my YouTube channel. Today I decided to complete exercise 3.1 so that we can move towards next exercises very soon, inshallah. So, without wasting any time, let's get started. In exercise 3.1, we have question number 2, and we have to write all these sets which are given in set builder form, and we have to convert all of these parts in the tabular form. Okay, we have already studied about tabular form and set builder form, what they are, what does their mean. So you have to recall them by using the link given in the description box by me. So click on it and do them clear, tabular form and set builder form. So we have to write in question number 2 set builder tabular form of the given set builder form. So question number 2, we have to write all parts in tabular form. Okay, first one we have x such that x is a multiple of 3 is a multiple of 3 and what is the condition? Condition is that x is less than or equal to 36. Okay, we have to list all the elements which are less or equal to 36 and they should be the multiples of 3. So what are the multiples of 3? 3 and then 6, 9, 12, 15 and so on, up to which number? Up to 36. 36 is included in this set because we can see here x is less or equal to 36. Okay, the part number 2 we have x such that x belongs to R. X such that x belongs to R means real number, and 2x plus 1 is equal to 0. Okay, we have to list elements which are going to be satisfied for this equation and what those elements will be. Those elements must belongs to set R. From R we have x is equal to minus 1 by 2. Then what this equation will be? Let's suppose 2x plus 1 is equal to 0. If we take x is equal to minus 1 by 2, then we have cancellation 2 and 2, minus 1 plus 1 is equal to 0 and 0 will be equals to 0. So this equation is satisfied for the element x is equal to minus 1 by 2. So this will be the solution set of this equation. And what other elements which are going to be satisfied for this equation? I think there is no other element which is to be satisfied for this equation. So only the tabular form of this set will be minus 1 by 2, which is the single element. So if we have a single element in any set, then we can say that this set is a singleton set. Singleton set. A set having only one element is known to be a singleton set. Okay, number 3, x such that x belongs to P and x is less than 12. What is going to be done? We have to list all the elements which are less than 12, but they should be belongs to prime numbers. And what prime numbers are? 2, 3, 5, 7 and 11. That's it, because we have to write all the prime numbers which are less than 12. Okay, let's move towards part number 4. In part number 4 we have x such that x is a divisor of 120. We have to list all the elements which are divisible by 120, and what those elements are. Those elements, first one is divisor of 120 is 1 itself, and then 2, 4, 8, 16, 32, 64, and 128 itself. So these all are the divisors of 128. What do you mean by divisor? Divisor means all those elements which are completely divisible by 128. Means whenever any number of from this set is divided by 128, the remainder will be 0. So these all are the elements which are the divisors of 128. Next we have part number 5, x such that x belongs to P and x such that x is equal to 2 raised to power n, where n belongs to natural number, and the condition is that n is less than 8. Okay, now we have to do we will take n is equal to 1 2 3 up to 7. Why up to 7? Because the condition is given that n is less than 8, so we have to take n is equal to 7 up to 7, taking from 1, because natural number starts from 1 to so on. So whenever we take n is equal to 1, we get 2, and when we take n is equal to 2, we get 4. If 3, then 8. If 4, then we have what? 16, and then 32, and then 64, and then 128, and that's it. Because if we take n is equal to 7, we get 128. 1 2 3 4 5 6 7. So all for the 7 natural numbers, this equation become this. So this is the tabular form of this set. Then we have part number VI, that is x such that x belongs to n and x plus 4 is equal to 0. Okay, which number these are? These are the natural number, and the condition is that x plus 4 is equal to 0. Means which number belongs to n, that is going to be satisfied for this equation. This equation is satisfied for that particular element. If we take n is equal to -4, then this equation will be satisfied. -4 plus 4 is equal to 0, and this 0 is equal to 0. So -4, x is equal to -4 is that number. When taking x is equal to -4 in this equation, then this equation will be satisfied. But the problem is that x is equal to -4 does not belongs to n. Why not belongs to n? Because natural numbers start from 1 2 3 4 5 and so on. It does not contain any negative number, so -4 does not belongs to n and hence we have its tabular form an empty set. So there is no solution set. If we have no solution set for the natural number in this equation, then the set will be empty set. Okay students, next we have part number 7. And what is 7? 7 is x such that x belongs to natural number and x is equal to x. It is very simple. We have to take natural number, and by putting those natural numbers one by one in this equation, then this equation will be satisfied. It is clear that this is x is equal to x. If we take n is equal to 1, then we have 1 is equal to 1. If we take x is equal to 2, we have 2 is equal to 2. If we take x is equal to 3, then this x will also be 3, and up to so on. It means this equation is satisfied for every element which is taken from natural set. So what would be its tabular form? Its tabular form is just like 1, 2, 3, 4, and so on. Okay student, next we have 8. And what is it but x such that x belongs to z, and z are the integers, and 3x plus 1 is equal to 0. Okay, now you have to identify that this equation will be satisfied at what point? When taking from z are the integers. If I am going to take x is equal to minus 1 by 3, then this equation will become 3 minus 1 by 3 plus 1 is equal to 0, and we have 3 and 3 cancel. Minus 1 plus 1 is equal to 0, and minus 1 plus 1 is equal to 0 is equal to 0. So this equation is satisfied whenever we take x is equal to minus 1 by 2. But integers are which type of numbers? They are the numbers like 0 plus minus 1 plus minus 2 and so on. Z does not contain any division numbers, like any number which is written in p by q form does not belongs to z. So minus 1 by 3 does not belongs to integers. So its solution set is an empty set, because at minus 1 by 3 equation is satisfied, but minus 1 by 3 is not an element from integers, so we have an empty set. Okay student, this is the end of our question number 2. Let's move towards question number 3. In question number 3, we have to find out the proper subsets of given sets. Okay, proper subsets, first of all we will define what is a proper subset. Let's suppose I have a set A which is equal to 1, 2, 3, and we have a set B which is equal to 1, 2, 3 and 4. If we look at both of them, then we can say that all elements of set A are contained in set B. Every element is present in set B, but there is at least one element in set B that is not contained in set A. Then we can say that A is super subset of B. Let's suppose we have another example. First we write like this: A is contained in B, and we can say that A is proper subset of B. Let's have another example. A is equal to 0, 1, 2, 3, and B is equal to 0, 1, 2, 3, 4 and so on. It is clearly seen that every element of set A is contained in set B, but here are some elements elements 2 or more than 2 that are not element of set A, then we can say that A is a subset, a proper subset of B. A is proper subset of B. Okay, now we have to write two proper subsets of the following sets in question number 3. Question number 3, write two proper subsets. Write two proper subsets. Okay ji, the first one is A, B and C. Then we have two proper subset, like I'm going to write like this A because it is contained in B, so we can say that this is the proper subset of this set. Let's suppose we have another set like BC. BC is contained in this set, so these both are the proper subsets of this set. In number 2 we have 0, 1. Let's suppose I'm going to write an empty set and then 0. Remember that every set has an empty set, so empty set is a proper subset of this set and 0 is also a proper subset of this set. We have to write only two proper subsets, so I'm going to write only two. You can write 3 and more. Okay, number 3, n. N is a natural number, and I can write let's suppose natural numbers is equal to 1, 2, 3 and so on. In one set I'm going to write 1, and the second will be 2 and 3. Okay, these both are the proper subsets of natural number, and in this way you can make a number of proper subsets of natural number. Because natural numbers are unlimited, you can make many more proper subsets of natural numbers. Let's suppose I'm going to take 101, 2000. These all are the proper subsets of this set. So here I have to write only 2, so these 2 are enough for this question. Now number 4, we have integers, and it is very simple. Natural numbers are starting from 1 and integers starts from 0 with plus minus sign, so natural number is one of the proper subset of Z. In the other set you can say that W is also a proper subset of Z. W means whole numbers. Okay students, let's move towards another question, that is rational numbers Q. Okay, rational numbers Q means is a set that is bigger than natural number, whole numbers and integers. So I can write for a rational number Q, the proper subsets are natural numbers, let's say, and you can say integers. Whole number is also a proper subset of Q. Let's move towards part number 6. This is real number. So real number set is more bigger than all the sets like natural number, integers, rational numbers, prime numbers. Every numbers are contained in real numbers. So let's take any two of them. Like I'm going to take one of them is rational numbers and then whole numbers. Both are proper subsets of real numbers. Okay ji, then we have part number 8, and in 8 we have x such that x belongs to Q and 0 is less than x is less or equal to 2. Okay, now we have to take elements from the rational number and keep in mind this definition. What are the x? X must be less or equal to 2 and greater than 0, and they must be rational number. And what are rational number? Rational numbers are those number which can be written in p by q form. P by q form means every number which is written in division sign will belongs to rational numbers. So the numbers greater than 0, less or equal to 2 will be number 1. I'm going to take 1. Okay, 1 by 2, and 1 by 3 is also 1 by 3, and 1 by 4. Okay, I am going to write them separately, or I am going to take only 2 of them because we have to write 2 proper subsets. Okay students, let's move towards question number 4. And what is that? Question number 4 is saying that is there any set which has no proper subset? If so, name that set. Is there any set which has no proper subset? No proper subset. Okay student, is there any? I think so. There is one of the set which have no proper subset for that. That is an empty set. An empty set is that set which have no proper subset. Okay, we have question number, this was question number 4, and this is question number 5. And what is that? What is the difference between AB and AB and AB? Okay, what is the difference between them? What does this mean? It means a set having 2 elements, and this is a set which is present in another set. Okay, and if we talk about this set, then in this set only one element present. Okay, what is the difference between them? This is a set having 2 elements, and this is a set having only one element. A set with 2 elements, a set with 2 elements, 2 elements, that is A comma B, A and B. And what is that? It's mean a set with only one element, that is AB. Is it clear now? Okay, next we have question number 6. In question number 6 we have to show all the power sets of the following sets. Okay, what is a power set? Power set can be defined by using formula like power set is that set which is represented by P of A. A is any set. Power set of A is equal to 2 raised to power n. Okay, let's suppose we have A is equal to 2 with two elements 0 and 2. Then we have this formula 2 raised to power n. What is n? N is showing that this set have only two elements 0 and 2. 1 2 two elements, it means n is equal to, here n is equal to 2. If we put here 2, then we get 4. So it means this set has power sets 4. There are 4 power sets of this sets with 2 elements. Okay, now we have to tell about the power sets of the following sets. Number 1, this is the question number 6, and number 1 is an empty set, and we have to show how many power sets of this set. So power sets having formula 2 raised to power n, and what is n? N are the number of elements in a set. How many numbers of elements in this set? This is an empty set, it has no element, so number of elements is equal to 0, and then we have 2 raised to power 0. Any number with power 0 will become is equal to 1. So this set has power sets 1, only 1 is the power set of this set. Okay, let's we have number 2 0 1. Here n is equal to 2. Now use the formula 2 raised to power n and 2 raised to power 2, and we have 4. Okay, number 3, we have a set 1 2 3 4 5 6 and 7. How many elements are there in this set? In this set n is equal to 7, so we have formula 2 raised to power n, and we have 2 raised to power 7, and 2 raised to power 7 will be equals to 128. It means this set has 128 power sets. Okay, let's move towards part number 5. I'm going to erase all of this. Next IV, and this is 0 1 2 3 4 5 6 and 7. Here n is equal to 8. Okay, now using this formula we have n to the power 8, and 2 raised to power 8 means 256. Okay, we have now A B C, part number 5. A B C. How many elements are there in this set? 1 and 2. N is equal to 2. So we have 2 raised to power n, and we have 2 raised to power 2, and we have 4. It means number of power sets for this set is 4. Okay, let's we have VI, and this set is AB, and then BC, and then DE. Okay, how many number of elements in this set? 1 2 3. Then n is equal to 3, and for the power set we have the formula 2 raised to power n and 2 raised to power 3 and 2 raised to power 3 will be equals to 8. So number of power sets for this sets are 8. Okay students, let's move towards question number 7. And in question number 7 we have to find out all the power sets of a given set. Number 1, write down the power sets. Write down power sets. Power set. Okay. Number 1 we have 9 and 11. Okay, in previous question we have already find out that how many power sets will be for this set. So again I'm going to take n is equal to 2 and power set, let's suppose this set if denoted with a, so power sets of a will be equal to 2 raised to power n and 2 raised to power 2 and will be equals to 4. It means this sets with 4 power sets. So p of a is equal to, let's start to write all the power sets for these sets. The first one is empty set. Empty set is always a set present in the given set. In any set, empty set is a subset. Okay, the first one is an empty set, then we have 9 and we have 11 and then we have both 9 and 11. So how many these sets are? 1 2 3 4. These are 4 power sets of this set. Okay students, let's we have a set having 4 elements in it. Then how many power sets will be? For 4 elements we have 16 power sets. Okay, in number 2 we have plus, minus, multiply and divide. Here n is equal to 4. Then how many power sets? 2 raised to power n and 2 raised to power 4 and 2 raised to power 4 will be equals to 16. It's mean you have to make 16 subsets of this set. Okay, let's start. We have this a, then power sets of a will be, number 1 is an empty set, number 2 we have plus, minus, multiply and divide. Okay, now plus, minus, plus multiply, then we have plus divide, now minus multiply, minus divide, multiply divide. Now we have plus, minus, multiply, and then we have plus, multiply and divide. Are you getting? Then we have plus, multiply and divide. Now we have minus, multiply and divide, minus, multiply and divide, and at the end we have all the elements at the last, plus, minus, multiply and then we have divide. Okay, let's count these. First of all close them in a bracket. 1 2 3 4 5 6 7 8 9 10 11 12 13 14 15 and 16. These all are the subsets and power sets of this set, and the number of sets are these 16. Okay students, now we have another part, number 3. In part number 3 we have only an empty set. This is the representation of an empty set. This is a empty set. Empty set. Okay, for this set, power sets, how many, first of all, how many number of elements in it? Only one. So n is equal to 1, and we have 2 raised to power n. 2 raised to power 1 is equal to 2. It's mean 2 will be the power sets of this set. Power set of A is equal to, first one is an empty set, and then this whole is an empty set. Okay, number 4. At number 4 we have A B C. A B C. Okay, how many number of elements here? Here are the 2 number of elements. For n is equal to 2 we have number of power sets 4. So let's start to write it. First one is an empty set, second will be A, third will be B C, and fourth will be A B C. All are together. Sorry, yeah, it's like that. Okay students, I hope you are now clear about the super subsets, power subsets, and how to write a set builder form in tabular form. Everything we have studied in exercise 3.1 from question number 2 to question number 7. And if you have any problem or any confusion or any query, any question about these questions, then please ask in a comment section. Okay, we will meet in our next video with another interesting exercise. Till stay safe, stay happy, take care, bye bye.